Good afternoon, dear students. Today we are going to see the 11th chemistry lesson, solution. In that solution, yesterday we have seen something. Today we are going to see the solubility and the factors affecting the solubility under Henry's law. These are the three topics which we are going to see today. What is solubility? Solubility. For example, if you take a solute in a fixed amount of solvent. If you are pouring a solute, what will happen? The dissolution taken place. The solute dissolve in the solvent. Totally you are getting a solution. There are three chances of solutions are there. One is a unsaturated solution. What is called unsaturated solution, sir? When, for example, if we are going to take NaCl if you take NaCl, if you take 20 gram of NaCl in 100 ml of water, 100 gram of water, what happens? All the 20 gram NaCl will be dissolving into the solvent. That means till if you add a 1 gram of NaCl extra other than the 20 gram, that also will be dissolving. That shows the solvent capable of dissolving till more amount of solute. That type of solution is called unsaturated. That means till we can till more some amount of solute can be added to that solvent that can dissolve. That type of solution is called unsaturated solution. Okay, if you take a 36 gram of NaCl from 100 ml, if you pour it after 36, everything will be dissolved. This is called a saturated solution. That means further more amount of solute cannot be added to the solvent. The solvent is completely dissolving only 36 gram of NaCl. 36 gram of NaCl. If I add till more 1 gram extra, that means 37 gram if I added, the 1 gram will be precipitated without dissolving. The NaCl, without dissolving NaCl will be there. So only 36 gram of NaCl is dissolving into that solution. If I add more than that, it cannot dissolve. So there is further no more solute can be added to the solvent. That is called a saturated solution. For example, if we are taking NaCl 36 gram only dissolved. If you add more NaCl to that, then it will be without dissolving precipitation will be occur. There will be a crystal undissolved NaCl you can see that. So only 36 gram NaCl in 100 ml, that is called a saturated solution. If I add more, maybe 40 gram or more than 36 gram, that is called a supersaturated. That is called a supersaturated solution. So these are the three different type of solutions: saturated, unsaturated, supersaturated. So each and every solute have a fixed amount for the solubility in 100 ml. So what is the solubility? If you define solubility is nothing but the fixed amount of solvent can dissolve the particular amount of, the specific amount of solute in it. That is called a solubility. For example, we are taking NaCl 36 gram of NaCl can be dissolved into the 100 ml of water. If I add more NaCl, there is no dissolution is possible. If I add then supersaturated solution, we can get. So that particular 36 gram is a solubility of NaCl. So particular or specific amount of solute can be dissolved into the solvent in a fixed amount of solvent. For example, 100 ml, 100 gram of solvent if we take, then 100 gram of solvent for NaCl, 36 gram. For a different type of solute will have a different type of solubility. Only NaCl I am giving you example like this. This is called solubility. The amount of substance dissolved in 100 ml of the amount of substance completely dissolved in a 100 ml of solvent is called a solubility of that particular solute. Okay. Then what are the factors affecting solubility? Factors affecting the solubility. Nature of solute and solvent. Nature of solute and solvent can affect the. Then temperature and pressure. These are the three factors which can affect the solubility. Nature of solute and solvent, then temperature and pressure. Nature of solute and solvent. For example, the same example we can take. NaCl is a polar compound. When it is dissolved into the water, water is also polar compound. The polar solute dissolved in a polar solvent. Polar solute dissolved in a polar compound. If I take NaCl in benzene, benzene is also used as a solvent. Benzene is a non-polar, there is no dissolving takes place. Okay. NaCl will only dissolve in a water like polar solvent. So, the nature of solvent decide that. How is it deciding? The polar solvent means polar solute. Non-polar solvent means non-polar solute. It cannot possible. The NaCl cannot dissolve in a benzene because it is a non-polar solvent. Like a polar solute can dissolve in a polar solvent. Then comparing ammonia and oxygen, if you take ammonia is more soluble in water. Okay, ammonia is more soluble in water comparatively oxygen. So different type of solute can have a different type of solubility, different extent. The solubility extent differently because if you take the gases ammonia and oxygen, both are gases only, but ammonia is more easily soluble than that of the oxygen. So thus the nature of solute and solvent decide the solubility. It can affect the solubility. Then let us move on to the effect of temperature. What is the effect of temperature? Effect of temperature in a solubility. Effect of temperature. How temperature affects the. If you are dealing with the temperature, you should know first what is the exo and the endothermic. Exo and endothermic. In a thermodynamics, you would have studied that exothermic and endothermic. In a chemical process, heat is released or given out. During the chemical reaction, heat is liberated or released or given out. Those processes called the exothermic. When a heat is intake, heat is absorbed, that process are called endothermic. Generally, temperature for exothermic process, when a temperature increases, solubility decreases. When a temperature increases, solubility decreases. For endothermic, temperature increases, solubility also increases. General concept is. Generally, temperature increases, solubility decreases for a exothermic process. For endothermic process, temperature increases, solubility also increases. That is for the endothermic process. Then, while dealing with the temperature, nature of the solute also meant for solute. Solute is solid solute in a liquid solvent. Solvent is a liquid. Okay. Solid solute in a solvent and liquid. What happens when a temperature increases? If a temperature increases, in this case, what happened to it? As usual, temperature increases, kinetic energy also increases. Kinetic energy also increases when it is a breaking of bond. There is new possibility or more possibility to join with a solute molecule. Exposed to solute, the solubility also increases. When a temperature increases, generally solubility also increases. Okay. When a solute is a solid and a solvent is a liquid. But whereas the solute is a gaseous state plus solvent liquid. What happens when a temperature increases, solubility decreases. When the temperature increases, solubility decreases. See here, solute is a gaseous form and solvent Here, if you increases the temperature, what happen? Increases temperature, mostly solubility decreases. Why? Because the same kinetic energy increases, kinetic energy of gases increases, the gas easily giving come out of the solution. Okay, it will come free from the bonding. The bond is broken. The intramolecular forces of attraction is reduced when the kinetic energy increases. Then the gas coming up. So the from the solvent. So there is solubility automatically decreases. Okay, let us have a graph-like structure for the fused salt solute. For example, NaCl, ceric sulfate, calcium chloride, and ammonium nitrate. Okay, if you have a graph, a temperature, how the temperature increases, solubility and temperature increases graph if you have, let me draw this. If you take, this is like, this is temperature go on increases. If you take solubility, like this. Okay. For NaCl, there is slight changes in a temperature increases, there is slightly changes. See how the changes you can apply slightly 10 times increases. When the temperature increases, solubility 10 times increases for NaCl. Whereas for the ceric sulfate, it is a endothermic process. Ceric sulfate is a endothermic process. So, sorry, this is a exothermic process. The sudden decreases. When the temperature increases, solubility decreases. This is NaCl. This is ceric sulfate. When the temperature increases, solubility decreases. Whereas ammonium nitrate, this is endothermic. Ammonium nitrate. This is endothermic. So solubility increases along with the temperature increases. Sudden increases. Solubility increases with the temperature increases. When a calcium chloride also is exothermic, but even it is some other factor is ruling, slightly increases. Calcium chloride also exothermic process only. This is endo. But as I said earlier, exothermic process, temperature increases, solubility decreases. For exothermic process, temperature increases, solubility decreases. But even though calcium chloride is a exothermic process, this other factor, that is del S value, entropy factor, plays a vital role in the case of calcium chloride. That's why calcium chloride also increases with the temperature increases. These are the different type of solute particle, how they are behaving with the temperature increases. Okay. Then let us move on to the effect of pressure. Effect of pressure. How the pressure affects the solubility. In two cases. What are the cases we have? Solute, solid, plus solvent liquid. What happened to that? When the pressure increases, solubility no effect, because there is solid solute cannot easily compressed. Okay, but there is no effect of solubility, pressure effect in a solubility. When a system is solute in a solid state and liquid is a solvent, there is no effect of pressure. Mostly there is no effect of pressure. Then whereas solute gaseous plus solvent liquid. In this case, when the pressure increases, solubility also increases. Pressure increases, solubility also increases. In the case of when a solute and a solid is a gas and solvent is a liquid, that is gas in a liquid condition, when the pressure increases, solubility also increases. Because when the pressure increases, solubility also increases. There is a equilibrium exists between the solute gas solute gaseous in a solution. This is a gaseous solute in a solution. There is equilibrium between this. According to Le-Chatelier's principle, always when a gas pressure increases, that is favored towards the right hand direction. According to Le-Chatelier's principle, pressure affects this. When the pressure applied here, the pressure always increases, the equilibrium tends to that where the number of moles is very less, the volume is very less. Here it is directing towards the forward direction. In equilibrium, we have studied Le-Chatelier's principle. According to pressure effect, says that whenever pressure increases, the equilibrium tends towards that where the volume is less. Volume is less. The equilibrium pressure increases, volume decreases. The equilibrium tends to that where the number of moles is very less. According to Le-Chatelier says that any disturbance given to the equilibrium will nullify the disturbance. If you add a pressure increases, then it is directed towards the forward direction. That is, more number of dissolution is formed. That is, gas will be more dissolving that gaseous state. Based on this, we have a Henry's law. Based on this, we have Henry's law to learn. What is Henry's law? That is, we are going to see now. Henry's law. Henry's law. Henry's law says that the partial pressure of the solute is directly proportional. Partial pressure of the solute is directly proportional to the mole fraction of solute in a solution. Mole fraction of solute in a solution. This is Henry's law. What is Henry's law? Henry's law is nothing but a partial pressure of solute is directly proportional to the mole fraction of the solute. See, what is the partial pressure? Pressure exerted by the solute particle in a solution. Pressure exerted a solute particle in a solution. That is called a partial pressure. That is a pressure of solute. Partial pressure means in a solution there is more component pressure is there. The individual component pressure is called partial pressure. That already we have seen in the gaseous state. What is the partial pressure? If a gas is contain more component, if a component A and B, A, B, C like this, A, B, C like this, more component in a gaseous form. If the total pressure is sum of the pressure exerted by A and B and C, so the total pressure is the total P, that is the pressure exerted by A and B, A, B, C. What is the pressure of A? That is called partial pressure. That is pressure of A plus pressure of B, pressure of C. So here we are considering the solute. So you take that pressure of solute is directly proportional to mole fraction. What is called mole fraction? Mole fraction is, you know very well, that is total number of moles of particular component divided by total number of moles. For example, if you take mole fraction of A, XA, that is mole fraction. X is common symbol to denote the mole fraction X, XA, then what the formula is number of moles of A divided by total number of moles in a solution. Total number of moles of A divided by total number of moles. That is called a partial mole fraction. So Henry's, according to Henry's, simply saying that when a pressure of solute is directly proportional to mole fraction. Simply, what is the Henry's law? If Henry's law says that when a pressure increases, solubility also increases. This is called in a gaseous solute. In a gaseous solute, where a pressure increases, solubility also increases. This is a direct meaning of Henry's law. According to Henry's law, what happened? Pressure effect to the solubility. Henry says that whenever pressure increases, solubility increases. Okay, let us go with it. So how is derived now? Partial pressure of solute is directly proportional to the mole fraction of the solute in a solution. Mole fraction of the solute in a solution. The partial pressure of solute, that is equal to mole fraction of solute. So in order to have a proportionality constant, we take KH X solute in a solution. Okay. Here, what is the KH? KH is a Henry's constant. Henry's constant. KH is nothing but a Henry's constant. Okay, pressure of the solute, that is partial pressure of solute, that is equal to KH into solute in a solution. KH is differ. Okay, KH is a constant. That is like proportionality constant. In order to remove the proportionality, we have a constant. K is totally constant. Here I am mentioning KH. H means for Henry's. That is Henry's constant. Okay. So this is a formula, that is KH equal to Henry's constant. Then the pressure of solute, simply write KH into mole fraction X. For X, if you take A, the solution gas, the solute may be A, XA, or XB like this you can say. This is a equation, that is pressure of the solute, that is equal to KH into XA. The KH is nothing but a Henry's constant. Okay. This is seems if you plot a graph between the partial pressure and mole fraction, you will have a graph in a straight line equation y equal to mx. You have a straight line equation, let's give a y equal to mx. Then slope value, always in a straight line equation you will have slope value, that is kh. You have a lot of problems may be asked. The problem based on this formula may be asked. They will give a partial pressure of the solute, they will give a mole fraction, some XA value, and KH, Henry constant is there, then they will ask a partial pressure of the solute. This is type of question. Then these two is given. Among these three factors, you can calculate in one. Okay, this is the problems you have in the book bag that you can go with it. You want to get if a graphical data is given for the graph, you may further be considering HCl gas. If you take a HCl gas, hydrogen fluoride gas, if you draw a graph between the partial pressure of the HCl and the mole fraction of the HCl, that is mole fraction of the HCl, that is X HCl. I am simply in the formula, I am writing A meaning anything, here I am taking HCl. If you take it will give a straight line originating to this. You can have a graph like this. Straight line graph. In a different level, you will have a graph like this. If you take a slope value, that slope value will give you KH, it is a Henry's constant, KH. Proportionality constant or Henry's constant, that we can say, KH value. It will give a straight line. Okay. So what is Henry's law? According to after this analysis, he is simply saying that pressure increases, solubility increases in a gaseous solute, in a aqueous medium. That a gaseous solute in a solution, liquid solution, when the pressure increases, solubility increases. That's it. For this, how he is relating this? No, pressure of the solute directly proportional to the mole fraction of the solute in a solution. Then the pressure of solute equal to KH. The proportionality is removed here. See here. Then KH equal to mole fraction of solute in a solution. What is called KH? KH is nothing but a Henry's constant. K is always constant we use. H is special case for Henry's constant. Then what is the partial pressure and mole fraction? That already we have studied. That is the thing. This is that. Then let us move on to the limitation of Henry's law. Let us move on to the limitation of Henry's law. It is only applicable moderate temperature and pressure. The Henry's law applicable only at a moderate temperature and pressure. You cannot apply at any temperature, any pressure, whether it's a low pressure or high pressure, you cannot apply to that. Only moderated temperature and pressure only you can apply, Henry's law. Then it is applicable only for less soluble gases. Less soluble gases. Less soluble gases only it is applicable. Then third, the solute should not dissociate or associated. Should not, the solute should not dissociated or associated in a solution, in a solvent. The solute should not dissociate or associated in a solvent. It is applicable only for a less soluble solution, and also we can say that it is applicable only for less reactive gases. Less reactive gases. It is applicable only for less reactive gases. Okay. For example, this case I can explain this. If you take ammonia, ammonia is easily soluble gases. Okay. Less soluble gases only you can apply, but it is easily soluble. Therefore, if you take ammonia in water, what is going to happen? Ammonia in water, this is going to happen. NH4 plus ammonium ion plus OH minus. OH minus. So, in this case, Henry's law cannot be applied. In this case, Henry's law cannot be applied because it is easily soluble and also it is dissociated into ions. So, what is the condition? Solute should not dissociate or associate in a solvent. Solvent is water. If you pour the water in ammonia, it is dissociated into ions. If like this dissociation taken place, you cannot apply Henry's law. The Henry's law cannot be applied for this. These are the limitations. What are the limitations of Henry's law? It is applicable only at moderated temperature and pressure. At moderate temperature and pressure. It is only possible at a less reactive gases. Less reactive or less soluble gases. Then the solute gaseous particle should not dissociate or associate with a solvent in a solution. If it is dissociated or associated, the Henry's law cannot be applicable. Okay, these are the limitations of Henry's law. Then let me explain some practical factors how the Henry's law or pressure effect causes. If we know why, the questions you may have, why the aerated drinks, carbonated drinks are pressurized in a closed container. What happened in the closed container? Because for example, aerated drinks, beverages, they are in a closed container only. The container is closed, highly pressurized and closed container. While opening, see, pressure increases, no, CO2. Aerated drinks mostly contain carbon dioxide, CO2. CO2 is there, aerated drinks, then it is dissolved into the water. Okay, so H2O plus CO2 is there, dissolved. When a more pressure is applied in a closed container, pressure is more, so it is completely dissolved. The air bubbles you can see. That is the bubbles inside the aerated drinks. That is a brisk effervescence we can say. That is brisk effervescence due to the dissolved carbon dioxide at a high pressure. While you open it, okay, this is closed container. When the cap of the container is opened, what happened? You may see the brisk effervescence coming out from it. That is why, because why there is coming out, already it is high pressure. It is dissolved in a high pressure. Pressure is more. While it open it is the pressure is dropped to the atmospheric pressure. What happening? Pressure is reduced. Automatically pressure is reduced. The dissolved gases particle will come out. That's why carbon dioxide, which is dissolved in aerated drinks, when you open the bottle, it is coming out because the pressure drops to the atmospheric pressure. Atmospheric pressure outside, other than the container is called atmospheric pressure. Within the container, the pressure of the container, while you open it, the pressure of the container drops to the atmospheric pressure. What happens? Ultimately, when the pressure reduces, the solubility decreases. That means already dissolved carbon dioxide will coming out of the bottle. That is, you are seeing the brisk effervescence. It happens when the temperature increases in warm condition. There is a bursting is taken place. Why? Because the temperature increases, pressure may be dropped. There is a bursting will take place. This is one example. Then another one example, the deep sea divers, sea divers, they are getting a helium oxygen mixture with the cylinder. Helium oxygen mixture is used. Why can't, sir? An ordinary cylinder cannot be used for the deep sea divers. This is because the same way, while they are going down, pressure is increases. If your ordinary container, the gas cylinder contains nitrogen, more number of nitrogen, oxygen and other gases, but the nitrogen is readily soluble when pressure increases. When you go down in the sea, deep sea, you are going, no, that if ordinary cylinder is used, the cylinder, inside the cylinder, what is the air is present, air contains nitrogen, nitrogen is start dissolving more. When the pressure increases, when you will go down the deep sea, you can, the nitrogen also readily soluble at the high pressure, because the pressure will be increases if going down. When you inhale that, it will absorbed by the inhale, it will enter into the blood vessels and all. Okay, no worry, because oxygen also is going, no, that is no problem. When you are ascending from the down to up to the surface, if sea level is there, if you go down the sea, you no problem. If the man is being with cylinder, no problem. You dissolve nitrogen also, you can inhale, no problem. When the man is coming up to the surface, the cylinder, what happened? Pressure variation is there, no? Here more pressure is there, then more dissolved nitrogen. If you come up to the surfaces, the dissolved gases, that is nitrogen, where pressure is reducing, nitrogen is coming out from that. When it is within the blood vessel, it will burst out from the blood vessels. Okay, this is called bend. That is technically called bends, they call it. It causes severe damage to blood vessels, and sometimes it may cause death also. That's why the CBD drivers, they are taking a helium and a oxygen mixture in the cylinder, this special type of cylinder. In that, instead of the more nitrogen, they add a more amount of helium in it. The percentage of nitrogen is reduced in the cylinder. The same thing happen. What is maybe it is less soluble. First thing, why helium oxygen mixture is chosen? That is, helium is less soluble. First thing, and another thing is it is very small comparatively nitrogen. The size of the helium is very small compared to nitrogen. It can come up in a blood vessels without damages. That's why we are preferring a helium oxygen mixture in a cylinder. That is a pressure effect. So far we have seen how pressure affects the solubility. Totally, entirely today we have seen what is called solubility, what is different type of solutions, that is saturated, unsaturated and supersaturated. Then what are the factors affecting the solubility. Then the different system of the solution, that is a solute may be solid, solute may be gaseous. If solute may be gaseous, how the temperature affects and the pressure affects, everything we have seen. So go with the book line, you will be very clear enough. Thank you.